Guys, we're starting IPsec today. In IPsec, we'll understand the entire infrastructure of IPsec, how does it work, and all the informations. So let's get started. Now, here I have given the reasons why we need a security over the internet. Like whenever you communicate through tunnel over the internet, why do we need a security? So reasons are we might need a multiple authentication methods, anti-cloning, right? Like DOS attack and all, preventing it from, right? After that, it might be from preventing your connection hijacking, man in middle attack. We need to apply encryption integrity. So all these things were required to implement to our data. See, ultimately, target is to implement data security. So these all were the reasons for which we implemented a security to our tunnel by the help of IPsec. In IPsec, multiple RFCs are there. So here you can see a reference number for ESP protocol, AH protocol, IKE V1, NAT-T, and we have ISCAMP protocol. Now, whichever I have noted here, guys, HMAC SHA, HMAC MD5. So whichever you see here, which I have noted down, which I have marked right now, these are very commonly asked questions, or you can say you can take a reference of these RFCs, right? For example, here I have RFC of NAT-T. Okay, so RFC NAT-T is 3948. Take a help of AI and you can say explain RFC 3849. I believe I give a correct one. 3948, sorry. 398. 3948. 3948. See, I didn't ask about any protocol. It will automatically tell me it is about a NAT reversal, which is NAT-T in short. Right? Normally, IPsec uses IP protocols like 50, which is not a TCP or UDP based. It's an IP layer protocol. But still, there is an interruption. There is an interruption of a translating device where a UDP port number 4500 is required. So basically, what I'm trying to tell here is later when you guys will know IPsec properly, that time, you know, in between while learning your IPsec, you guys can refer to these RFC numbers and know the details. This is what I mean. And when you guys go for an interview, that time you can give a reference like as per the RFC 3948, these are the details. So interviewer will understand, okay, this guy has an idea about RFC. He has gone through these documents. They will understand. So you are telling as per the reference of RFC. This is what interviewer will understand about you, right? Which is good. So always try preferring go for IPsec. Now IPsec, I would like to ask you guys, what is IPsec? How do you define IPsec, guys? Tell me. How do you define IPsec?
Um, IPsec.
IPsec is a protocol suite which encrypt which creates a tunnel uh, between two network point.
Okay. More?
IPsec secure communication by creating an encrypted tunnel.
Encrypted tunnel, okay. See, I'll tell you how to give a definition of IPsec. whatever you told is fine, but not the way it should be. When I talk about what is IPsec, see what is definition mentioned here. IPsec is a framework of protocols and it's open standard. See, every points are necessary to include. IPsec is a framework of protocols and it's open standard. Framework of protocols means it's not a single protocol, rather it's a suite of protocols, right? It's a suite of protocols, means it's a collection of protocols. So definition would be IPsec is a framework of protocols, means it's a suite of protocols or it's collection of protocols, and it's an open standard. So we can communicate between different vendors by using IPsec. It can be Palo Alto, Juniper, Palo Alto, Cisco, any other firewalls or devices. If you want to make a connectivity between them using IPsec, you can. The main objective of IPsec is to provide a set of cryptographic method. Now, like in our previous class, we studied like cryptographic methods, encryption, hashing, different type of keying methods. So if you want to apply all those algorithms, you need a protocol, and that protocol is IPsec. That's why it's written here. The main objective of IPsec is to provide a set of cryptographic method. So cryptographic method includes encryption, hashing, authentication, everything, right? So in one word, you are telling everything. To protect IP packets at layer 3. Most common implementation of VPNs at layer 3 secure implementation, guys. IPsec is not only a protocol, it's not a single protocol, rather it's a suite of protocols used to provide these services. CIA, we have confidentiality, which is encryption, integrity, which is hash, availability, which is fine, which availability basically means a backup. Okay. Authentication, which basically identifies who you are, and a replay protection. So whenever a replay protection is a kind of a mechanism which actually verifies a data going through initiator to responder and responder to initiator, right? With some nonce value. There is a term used called as a nonce value. Okay. Now, what is nonce value? You guys do research meanwhile. Till I reach for this explanation, meanwhile, you guys do a research about what is nonce value, what is authentication, what is availability or a backup, what is integrity or a hash, confidentiality. I mean, these things already I have explained to you guys in a previous class. I have already given an explanation on all these things. And this is the additional thing which I have added here, replay protection, which uses a nonce value. So you guys do a research about what is nonce value, because this part will be covered in next class. Okay. Now, I was discussing about IPsec protocols. So here under IPsec, we have 3 protocols. Okay. I'll basically show you a different graph as well. Now see guys, this type of graph which I have created here, it's my own creativity. Okay. You don't find these things in book or I mean the other places. So basically, this is my way of understanding IPsec. If you ask me, how did I understand IPsec? Now, this is the framework that I created myself for myself to understand. And I felt this is one of the best way of understanding. And I want you guys to follow same. Okay. So first of all, guys, 1 minute. 1 minute. Okay. Okay. So under the IPsec, we have multiple protocols. We have IKE, ESP, and AH. For your information, guys, IKE is not a protocol actually. Okay. So why do I call it protocol? Under IKE, we have multiple protocols. Okay. Under the IKE, what is IKE? Understand, IKE is Internet Key Exchange. It's a method. It's a way of exchanging the keys over the ISP. And it uses a protocols like ISACAMP, OCLE, SKME, right? This type of keys are used. Mostly we use ISACAMP protocol. So we also call IKE as a protocol. Like IPsec is not a single protocol, but still we call it as a protocol because under IPsec we have multiple protocols. Same way, IKE is not a protocol. Under the IKE we have multiple protocols. IKE is basically an internet key exchange method, but still we call it as a IKE to represent the further informations, right? So if you guys are asked what are the protocols under the IPsec, say IKE. But IKE is an internet key exchange. It's a method of exchanging the key over the ISP. Under the IKE, we have multiple protocols. First, you say IKE has two versions, IKE v1 and IKE v2. And further, multiple protocols are used under the IKE. That's how you define the IKE. Again, you will say IKE also has ESP protocol. ESP stands for Encapsulating Security Payload. It means you can say, like for understanding purpose, I'm telling this is ESP. Under the ESP, there will be payload. Payload means your information. Let's say that this is ping request. So ping request is your payload information. And this is encapsulated by which protocol? ESP protocol. And with ESP, I'll apply AES plus I'll apply SHA-1. So with ESP, I can apply encryption and I can apply hashing. This is what it means. It means this can be encrypted and a hash value can be added. So it's written ESP is neither a TCP based, neither a UDP based. It's a layer 3 protocol. So it has a protocol number 50. It supports both encryption and authentication or integrity. Integrity is nothing but hashing. Whereas AH protocol is also a encapsulating payload. It also does an encapsulation. For example, if this is my telnet request, right? I'm trying to telnet somewhere. This information will be encapsulated under AH protocol. So AH will be used, but AH supports only hash, or you can say authentication. Okay. It does not support encryption. Clearly, I have mentioned. This is also layer 3 protocol. Protocol number is 51, 50, 51. Like this, you have to remember. AH supports only authentication. It does not support encryption. Don't say outdated, guys. Say rather, it is used for monitoring purpose. Okay. If you want to monitor your VPN traffic, if you want to test, you can say it is used for testing purpose. Used for testing. Testing in the sense we basically test our packets, headers, how many size of packets are passing. Is it exceeding 1500 MTU size or what? So I can check each and everything. And AH is also a very important protocol for a real time, for testing purpose. Okay. It's very, very important point, guys. Right? So, in a real time, I need both encryption and a hashing. So, there is a question for you guys. If I need encryption and a hashing both to a data, to a real data, which protocol should I go with, ESP or AH?
That would be
ESP,
ESP.
ESP.
ESP protocol. Okay. But if before applying a tunnel or before implementing tunnel to a real time, I want to test, I want to see how packets are passing through a tunnel, right? Before officially launching VPN, right? I want to see unofficially, I want to test how the packet size are passing through the tunnel. So which protocol can help you? Can ESP help you in that case?
No, you use the H.
No, you can't get a help with ESP because ESP will do encryption plus hashing both, right? So that's a difference between ESP and AH. And very commonly asked question, what's the difference between ESP and AH? Guys, keep in mind, VPN, whatever I'm teaching you right now, initial phase, whatever theoretical part I'm teaching you, please take it very, 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 very seriously because these are the questions which comes from a VPN and this will help you to grab your opportunity. Nowadays, either you belong to routing switching background or you belong to security background or you belong to data center background, anywhere. Everyone should know IPsec. And none of you guys can give excuses like, I'm not a background of security, I'm not having a background of this, that. No, IPsec should be known by everyone. So be careful and try to raise a questions, try to learn. Ask me subjective questions. Sometimes you can go out of context also for your curiosity. That is fine. But whatever we are into right now, let's say we are into IPsec. So related to IPsec, whatever you guys feel, you can ask me. Okay. Now, till this point, follow this document, guys. After that, please follow the other document which I'm going to show you right now. This one. Use this PPT for your reference. Okay. Use this hierarchy to understand your IPsec. Now, you guys will say under IPsec, we have IKE, ESP, and we have AH. Three different protocols. Protocol number of ESP is 50. It supports encryption and hashing. Protocol number of AH is 51. It supports only hashing, does not support encryption. Purposes are different. Purpose of ESP is to encrypt your real data with a hash value. AH purpose is only to AH's purpose is only to add a hashing value, not to encrypt your data. It is used for testing purpose. So the purposes of these two protocols are different. They are not same. Okay. Now, you can't say any protocol number. You can't have any port number because IKE is a method. Under the IKE, we have two versions. Understand? IKE has two versions, IKEV1 and IKEV2. There are two versions of IKE. After some time, you might hear there is IKE version 3. So whenever it will come officially, that time will come to know. Let's ask our chat GPT. Do we have IKEV3 in IPsec? No, there is no IKEv3 in IPsec. IP security has only two versions as of now, which is IKEv2. Okay, another question. Is there a plan of creating IKE version 3? Yes, there is a plan going on. There's no officially plan, but unofficially, yes, there is going on. Because IKE v2 is designed to be a modular and extensible. New capabilities can be added without creating a new IKE version 3. Okay. See, unofficially, things are there. I had seen somewhere, but ChatGPT is denying about it. But Google it, guys. Okay, you will get some information about IKE v3 in future getting planned. Like why I'm telling you, IK, sorry, there was IPv4, right? In between, there was IPv5 as well, which never got implemented, and later we planned for IPv6. So if you guys see, if you ask ChatGPT, hey, was there IPv5? See, it was an experimental protocol, right? It was there. So many things you guys can, know from the ChatGPT. You can know it from the virtual AI. But guys, you have to write correct prompt. The information, whatever I'm typing here, right, that matters. So how likely you are typing the information here, that matters. Accordingly, you guys will get the entire information from ChatGPT and all. No matter whichever AI you use, your prompt should be correct. That's why we call it as a prompt engineering. Okay. Guys, all of you, once again, please give me a confirmation. Till this point, and IKE having two versions, till this point, am I clear to all of you?
Yes, sir.
Yes, clear.
Yes, sir.
Yes, sir.
Okay, fine.
Sir, sorry, yeah, I'm late today. Can you come again for me? If it's not possible, I will follow the video after. Thank you.
Uh, pardon, pardon me, guys. Can you tell me once again? What did you ask?
I'm saying I'm connected now. All the class now. I'm late.
Okay,
I'm
okay,
late.
okay. You joined a little late. Yeah, okay,
Yeah.
no problem. Yeah, no problem. Please go through this video properly. Okay, because understanding of IPsec is very, very important. Very, very important. Now, let's move on, guys. We are getting into IKE v1 and IKE v2, but we'll understand only till phases of IKE v2. IKE v2 later I'll explain again. First, we have to complete IKE v1, IKE v1 phases, IKE v1 modes, and message exchange, so on. We'll go first of all in this way. Okay. Now, let's understand IKE v1 has a phase 1 and phase 2. IKE v1 phase 1 name is ISACAMP, and IKE v2 phase IKE v1 phase 2 name is IPsec. Any particular protocol used by IPsec? Not like that. See, there are multiple protocols under the IPsec. Like we have ESP, we have AH, we have ISACAMP, we have NAT-T. These are most commonly used protocols under the IPsec. ESP, AH, ISACAMP, NAT-T. These four protocols are commonly used under IPsec. Okay. Guys, now let's understand IPsec has IKE. IKE has two versions. IKE V1 has two phases, phase 1 and phase 2. IKE V2 also has phase 1 and phase 2. Okay? Guys, there is one confusing type of thing that you guys have to understand. Okay, you have to digest it. There is a protocol IPsec, there is a protocol ISACAMP, right? Now I'll tell you one more thing. Now, there is name, and names are IPsec and ISACAMP. There is a name, like my name is Sushil, right? My name is Sushil, but name has meaning as well. Sushil name means peace, right? Same way, here IPsec or ISACAMP is a protocol, not a name, but somewhere IPsec and ISACAMP is used as a name, not as a protocol. Two different things. Please understand. Please understand what I'm trying to tell. There are conditions where IPsec and ISACAMP is used as a protocol, and there is a condition where IPsec and ISACAMP is used as a name. Okay? Like, for example, which protocol are we learning? We are learning IPsec protocol, right? Which protocol is used to carry these messages? ISACAMP protocol is used. So this was the use of protocol. Now understand. IKE V1 has two phases. Name of phase 1 is ISACAMP and name of phase 2 is IPsec. Guys, are you understanding what I'm saying? Did you understand protocol and did you understand name? Where to use name and where to use protocol? Are you getting
Yes,
something?
yes, yes.
Ivan,
Yeah, all
Pepe,
clear.
you getting my point, what I'm trying to tell?
Yeah, absolutely. It's clear.
Okay. So, Pepsi, are you understanding? Not only 2 p.m. guys, even 6 p.m. guys, tell me, you getting my point?
Yes, sir. Yes, sir.
Okay, perfect. I'll ask you again. Now, understand here, IKE V2 also has phase 1. Name is IKE SA init. and phase 2 is named as IKE auth. Okay, so here keep these things in mind about IKE v1 and IKE v2. There is a common part between IKE v1 and IKE v2. Common part is IKE v1 also has two phases. IKE v2 also has two phases. This is common part. Okay. So till this common part, you have to remember, and also you have to remember their names. IKE v1 phase 1 name is ISACAMP. IKE v1 phase 2 name is IPsec. IKE v2 phase 1 name is IKE SA init. IKE v2 phase 2 name is IKE auth. Simple. This much we have to remember initially. Now we are moving towards IPsec IKE under the IKE v1. Under the IKE v1, now we are moving here. We are taking this IKE v1. Right now, forget about IKE v2. IKE v2 will understand after completing IKE v1. Okay. So let's understand IKE v1 first of all. See guys, now how things you will tell. I know IPsec. Under IPsec, I know I have IKE. Under the IKE, I have IKE v1. Under the IKE v1, now we are understanding. Under the IKE v1, I have phase 1 and I have phase 2. This is how you guys have to understand. Okay. IPsec, IKE v1 and IKE v1 having phase 1 and phase 2, right? Okay, if this much is clear, now understand IKE v1 phase 1 has two modes. One is called main mode, other is called aggressive mode. And phase 2 has quick mode. Phase 2 has only one mode, which is called quick mode. Okay. So, again, repeating, IKE v1 has two phases negotiation. In a phase 1, we have two modes, and phase 2 has a quick mode. So, from phase 1, I can take any one. I can't take both at a time. No, I can take only one at a time. So, main mode and quick mode, or aggressive mode and a quick mode. Two combinations can be there. So here I have main mode, quick mode, or I have aggressive mode and a quick mode. Two combinations can be there. If I use main mode, then total 6 message exchanges will be there. To complete main mode, total 6 messages are required. So 6 messages, and for a quick mode, 3 messages are required. 3 messages. So total 9 message exchanges, maximum 9 message exchange. But if I go with aggressive mode and a quick mode, aggressive mode has 3 messages, quick mode has 3 messages, so total 6 messages required to create a tunnel. To create a complete tunnel, either it can be 9 messages or it can be 6 messages. 9 messages means main mode having 6 messages and quick mode having 3 messages. 6 messages means aggressive mode and quick mode 3 plus 3 equals to 6 messages. Guys,
Sir,
is this?
here message means
I'll tell you. Message means what? I'll tell you. Like, okay, message means what? I'm trying to explain you. When you do three ways handshake in a TCP to establish a connection, when you do three ways handshake, that three-way handshake is like from a client, we send a SYN packet, and from the server, we get SYN plus ACK, and again, client gives ACK for that. So these are called three message exchanges. So in a TCP connection, we have three message exchanges to establish a connection, right? Same way, we say in a main mode, in a phase one, we have six message exchanges to establish phase one tunnel. Clear? So there will be two different sites, and between two different sites, we'll exchange messages. For example, here I'll show you. Understand, let's say here I have a one router, which is initiator, and here I have another router, which is responder. So from one router, I'll send a first message, a request, and I'll get a reply. Again, I'll send a request, I'll get a reply. Again, I'll send a request, I'll get a reply. So total six message exchanges will be there, and then it will establish phase one main mode. Same way, in a quick mode, we'll have three message exchanges, okay, and we'll have quick mode established. So message exchange means I'll give you information, you will agree on that, you will reply me back. Again, I'll send you some information, you will send some information. So this is called message exchange. So total six messages are required in a main mode and three messages required in a quick mode. From a phase one, if I take aggressive mode, so three messages, and from phase two, if I take quick mode, then for phase two, I don't have a choice. It's only one mode that is called quick mode. Okay, I don't have a choice. So phase one has a main mode and phase two has a quick mode. So this is one combination. Again, I'll have an aggressive mode and a quick mode and six message exchanges. That's a second combination. Guys, till this point, am I clear? Whose question was that? What is message?
yes, sir, yes.
Okay, perfect. Now, understand which is a secure way of communicating. Main mode, quick mode, or aggressive mode, quick mode. Which is secure one?
I think it will be main mode and quick mode because of the number of key exchanges, the nine key exchanges.
Abdul, will come to those timing parts itself. Okay, but as of now, first of all, understand all these messages, then we'll come to timing part. Okay, let's not move forward because there are many things to understand inside each messages. After that, timing part will come. Okay,
Okay, sir.
there are many timers that we have to understand. Step by step. So guys, which would we prefer? Main mode, quick mode, or aggressive mode and quick mode? So answer is main mode and a quick mode is known as a secure and it is used in a real time. aggressive mode and quick mode is not secure. And why it's not secure, we'll come to know only when you know main mode. If you know main mode, you'll know aggressive mode properly. If you know quick mode, right? So quick mode does not have any alternative things to understand. Main is main mode. Understand main mode. Other modes will be easy to understand. You'll easily understand quick mode. You'll easily understand aggressive mode, everything. So guys, focus here, main mode. Okay. Guys, when I talk about a main mode, when I'm discussing about a main mode, so can you guys give me a path how to reach main mode? Like from where do we start? First of all, we start with IPsec. Under the IPsec, what do we have? What do we have under the IPsec?
IKE.
I.
IKE.
IKE.
Under the
IKE version
We have
1.
and
IKE
version
version
2.
1. Under IKE version 1,
And then
We
phase
have
1.
two phases.
we have phase 1. I'm talking about main mode. So tell me only about main mode. So we have phase 1. Okay. On inside of phase 1,
Isacam.
we have main mode or we have a aggressive mode. We have two things. So this is how you guys have to understand. Now, after this complete understanding, if you go through any books, you can easily understand. Read any book, you can easily understand IPsec. Okay. So guys, now our target is to understand message exchange. We'll understand the message exchange of main mode. We are understanding main mode 6 message exchanges. This is where we are now. Let's take 5 minutes of break again, then we'll start. Okay. Okay, I'm back.
Okay, sir.
Okay, let's understand now. Guys, one thing I have to cover before covering this message exchange, this part is important. Okay. In a VPN, we have two phases, right? We have a phase one and we have phase two. Phase one is called control plane, and phase two is called data plane. And these two phases negotiation. Okay, guys, in a phase one, how many message exchanges are there? If I have a main mode, how many message exchanges are there? And in a phase two, what is the mode? Phase one,
Six
how many
message.
main mode? How many message exchanges?
9.
9.
I'm asking about phase one main mode.
Okay,
Main mode we have
6.
6.
We have
six.
six message exchanges. And what is phase two called?
Data plane.
Backup.
Phase two is a quick mode.
It's a quick mode.
Oh, quick move.
Who said backup? Huh? Phase two is called quick mode. And how many messages do we have in a quick mode?
Free message.
We have three message exchanges. Now understand, phase one is called control plane. So main mode works for control plane. And phase two is called data plane. So quick mode works for data plane. It means all decision makings will happen at your control plane and data will be forwarded. If your control plane is established, then only phase two will get established. If control plane fails, your data plane will also fail. Okay. So while establishing a tunnel, first phase one tunnel gets established, then only phase two tunnel gets established. Understood? So while doing a troubleshooting in a real time, check, is phase one okay? Is phase one getting established? If phase one itself not getting established, then don't go for phase two. There is no meaning of phase two then. So if phase one is established and then phase two not getting established, then there is a problem with phase two. Okay. But if phase one itself is not getting established and then you're troubleshooting phase two, it's a wrong method. So what is the use of control plane and what is the use of data plane? We'll understand in this message exchanges. But before that, understand this IKE V1 phase 1 or phase 2 or a IKE V2 phase 1 or a phase 2. This entire message exchanges will pass through a protocol called ISACAM. All message exchanges, I mean this 9 message exchanges will pass through a protocol and that protocol name is ISACAM and that ISACAM uses a UDP port number 500 for source and a destination. Let me show you guys. I have one Wireshark captured packet. Okay, I guess I have it. Somewhere I might have kept it. Okay. I don't find it. IPsec main mode Wireshark packet, Wireshark capture. It's a PCAP file, guys. Let's see if anyone has uploaded anywhere. Okay, this is the packet. Now you guys can see here. This is Wireshark packet, guys. Okay, this is PCAP file. PCAP is an extension of your Wireshark. You see, this is main mode. Okay, main mode. Guys, count it total. How many messages are there for main mode?
6.
6.
And for quick mode, how many messages?
3.
3.
So total 9 message exchanges. And all these 9 message exchanges are carried by which protocol?
As a camp.
ISACAMP protocol. All right. And here, ISACAMP is what? Internet Security Association and Key Management Protocol. And see, this ISACAMP packet is carried by which protocol?
UDP.
ISACAMP is a UDP based protocol. And what is the source port and destination port used by ISACAMP?
500.
500 for source and 500 for destination. So if you get a question in an interview, like which protocol carries phase 1 and phase 2 information, message exchanges, information message exchanges, same thing. Which protocol is responsible for carrying phase 1 and phase 2 information? What should be answer, guys?
ISACAMP.
And how does ISACAMP work? How does ISACAMP work?
It could be ISACAMP uses the UDP protocol 500 to work.
Correct answer. But you have to explain it properly. You have to say ISACAMP protocol.
Okay.
It is UDP based protocol. It uses a source and a destination port number 500.
Okay,
Don't
sir.
forget to mention source and a destination port number 500.
Okay, sir.
See, guys, generally, whenever you guys are communicating, right, your source port is dynamic and destination port is fixed. right? Generally, whenever you do a communication, your source port is dynamic and destination port is fixed. General communication I'm talking about, right? But in the case of ISEC, my source port and destination port both are fixed. It should be 500 only. Okay. Now, let me ask you a question, guys. Just I'm willing to know how much you guys understand this packet part. I need at least 4 or 5 hours more to make you understand IPsec. 4 or 5 hours more theoretical part I need to explain you guys. After that only you can understand IPsec properly. Right. So here I'll open my EVNG. Just creating one demo lab to show you. For example, I have one router. Let's say this is my telnet server and I have a PC. I don't have a PC here. Let's say iOS. I'll take another router. Guys, please mute. This is client. So I have a server and I have a client. Let me start both of them. On server, I'll give a IP. Interface G0 by 0. IP address 10.11.11.1. Mask of 24. Interface Z0 by, okay, just copy this, paste it here. This is on client. Post name, client. IP address, I'll give it 2 here. That's it. Let me get console of both the devices. Let devices come up, guys. Okay. It's starting right now. Let it come up.
Regarde-toi de question.
Guys, a little louder. Tell me.
I just asked to press enter.
You asked about what, Alan? I didn't get you. Could you type, Alan? Please type. Ellen, please type a message. So here I'll take client configuration. I'll paste it here. I'll take, actually my laptop sound is less. Next class onwards, I'll put a small speaker so that I can hear it properly. Okay. Okay. Guys, on a server, I'll enable telnet. Line VTY04, password Cisco, transport input telnet, done. I'll go to a client and I'll telnet server. But before that, I want to capture a packet. So right click on a device, go to capture. In a capture, which interface? Here I have G0 by 0. So click on G0 by 0. Open Wireshark. In this black screen, it should not show you denied. Okay, if it shows denied, then you have to fix the issue. So for me, it's all good. And I'll go here to a client and I'll try to telnet 10.11.11.1. I got the access. Now, here, telnet was TCP based. So since in ACK, I can see here, there was a telnet data. I can see this. So what I'm trying to show you here, when I tried telnet, right? When I tried doing a telnet, my source port number here. My source port number is dynamic. And if you see destination port number, it is fixed. Source port number will keep changing as many time you reconnect. This will keep changing. This is called dynamic port. But a destination port you're trying to telnet, that will remain fixed. Why? Because you're trying to telnet. This is changing and this is fixed, source destination. But in the case of ISACAM, so I wanted to give you a clarity on ISACAM. In ISACAM, it's not like that, guys. In ISACAM, my source port should be 500 and destination port also should be 500. If this port number changes, hash value will change. And if a hash value changes, your packet will get dropped. And this situation will come. It will come where a hash value will change. And there is something called as a NAT T. Guys, all of you take NAT T as a task. In a next class, I'll ask you guys about NAT T. What is NAT T? I'll ask you this question. Very important point. Okay. What is NAT T? That's my first question. And Haggle, Haggle, Haggle process. What is Haggle process? I need an answer of this as well. Okay, so slowly you'll understand all this stuff. Guys, regarding ISACAMP, that ISACAMP is used to carry entire information of your phase 1 and phase 2 tunnel. And ISACAMP works with UDP port number 500 for source and destination. Right? Main mode and quick mode both comes under IPsec. All these points, am I clear to all of you?
Yes, yes.
Yes, sir.
Yes, boss.
Perfect.
Boss, I have one question.
Yes, please tell me, Alan.
Yeah, my question is regarding the capture of IPsec IKE version 1.
Okay.
Yeah. When I saw the protocol is carrying the message here for main mode or quick mode,
Uh-huh.
I have just ISACAMP. Why?
Oh, because it is predefined. Okay, IPsec uses ISACAMP protocol for main mode and a quick mode. Okay, it does not use any other protocol. It's a hard coded inside. It's programmed in such a way. Okay, because ISACAMP is only the protocol under ISACAMP. Sorry, under the IPsec, which is used for phase 1 and phase 2 message exchange. Only for message exchange, not for a real data. See, this point, till this point, your tunnel establishment has happened after 6 message exchange. After 6 message exchange, your phase 1 has been established. After 3 message exchanges of quick mode, your phase 2 tunnel has established. So, to exchange information between two sites for these two modes, it uses ISACAMP protocol only. It is predefined with your IPsec. But till now, our real data hasn't passed. Okay. So when does a real data pass? Now, after completing quick mode message exchange, there will be a real data. So here I have now the real data. And this real data is protected by ESP protocol. So basically, now this real data will be encapsulated and encrypted by a protocol ESP. Now ESP comes into a picture. So which protocol is used for real data protection? If question comes, it's ESP protocol, right? In IPsec, we were learning about multiple protocols, right? So question would come, where is ESP or AH used? So the answer is, after completing main mode and quick mode message exchange, right? After the phase 1 and phase 2 establishment of tunnel, when real data passes, that real data is protected by ESP protocol. So every phases or every situation has a protocol. Understood? Now I can't use ESP protocol to exchange the messages. No, I can't do that. And why I can't do that? Because it is designed in a way where every protocol has their own responsibilities. ESP can't take a responsibility of ISACAMP. ISACAMP can't take a responsibility of ESP. That's how it is designed, right? So ISACAMP responsibility ends till exchanging the messages. Now there are multiple variants inside. ISACAMP right now uses UDP port number 500, but there can be a situation where ISACAMP ISACAMP might be using UDP port number 4500 for source and UDP port number 4500 for destination. Now why does it use? For that we have to understand. Now how do you say that? Let's see. NAT T Y shark capture. NAT T, if we have anyone in the community, let's see. NAT T. Okay. 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 Can you see here, guys? I have ISACAMP protocol, right? But after now here ISACAMP source UDP port number 500 for source and destination, right? But after certain situation, story changes. After certain part, story changes. Can you see here now how story has changed? The same ESP, same ISACAMP protocol has changed the story now. Now it is using UDP port number 4500. Now why is that?
Because it is passing through the NAT.
Because the translation, it is passing through the translated packet. I mean the device. You see which message exchange. This is fifth and sixth message exchange, where it used 4500. Why not till fourth message exchange? Why didn't you use 4500? Situations are different, right? So you have to know all this stuff. Alan, you getting my answer?
Yes, I get you very, very well, but I'm not comfortable on that. When I saw the architecture of IPsec, okay,
Mm-hmm.
on IKE phase one, okay, we have two phases,
Mm-hmm.
okay, we
Mm-hmm.
have the phase one ISECAM and phase two IPsec,
Correct.
okay,
Mm-hmm.
but on phase one we have ISECAM, which we have many mode and uh, and which mode?
Aggressive mode, yes.
Yeah, aggressive mode. And
Mhm.
phase two, we have quick mode.
Correct.
But all when we are seeing the capture of IC camp, okay,
Mm-hmm.
I see quick mode and many mode, okay.
Mm-hmm.
It seems we have two phase here, but why the protocol appeal just the IC camp on quick mode?
Okay.
That is,
Okay,
yeah,
okay.
yeah.
I got your confusion. Okay.
Uh,
See, at the beginning of IPsec, when I started explaining you these things, I told one thing, if you guys remember. I told one is protocol. So protocols are IPsec and ISACAM, two things. And another part is name. Okay. So name is also used as ISACAM. Okay. And IPsec. Now here, if I ask you, hey, which protocol are you learning right now? Your answer will be, I'm learning IPsec protocol. Under IPsec protocol, which other protocols do you have? Your answer will be, I have ISACAMP protocol, I have ESP protocol, I have AH protocol. So depends on what question you are asking. My question is about protocol. Fine. Now here there is a little, the way you understand the concept. Here, my question is under IKEV1, what is the name of phase one? Name. I'm not asking about protocol. What is the name? Name is ISACAMP. So what you understood is, if the name of phase one is ISACAMP, then for phase one main mode, only ISACAMP should be used. And if the name of phase two is IPsec, then IPsec protocol should be used. You got this type of confusion. But what I told, this is not the case. This is what you have to clarify. You have to understand. This is not the case. If I ask you, hey, tell me what is the name of IKV1 phase 1, then you have to say name is ISACAMP. What is the name of IKV1 phase 2? Name is IPsec, not a protocol. This is not a protocol. I'm asking about a name. Now, if I ask you, hey, which protocol is used to carry phase 1 and phase 2 information, messages? Then your answer should be protocol. Which protocol? ISACAMP protocol. So you can't relate that ISACAMP name should have ISACAMP protocol only, and IPsec protocol should have IPsec protocol only. No, you can't relate it this way. Protocol is used to carry the information, and name is to represent the phases. You getting my point, Alan?
I get you very well, boss. Thank you.
Okay. Thank you. Okay. So I guess, guys, whatever I have told you the information right now, try to understand that. Okay. And make arguments on that. Like right now, Alan tried asking me question, right? So I could understand where he is getting confused. Same way, you guys also please try to raise a question in a class. And to raise a question, you have to study first of all. So I'm giving you some time. Whatever we have explained today, please go through that video properly. Make a note of each and everything. Okay. Only having lots of theory and not understanding anything does not make any sense. Okay. Having a class for 3 hours but not able to digest it does not make any sense. So whatever we have understood today, make a proper note of all those things. And I have a task for you. Task is, I want you guys to understand, I want you guys to do research of this main mode 6 message exchanges. So you guys have to do research of 6 message exchanges. Now 3 messages, first message, third message, and fifth message will go from initiator. Like I'm initiator, you are responder. Yes, Nihal. I have already uploaded. Please check the Google Drive. Guys, all of you, please check a Google Drive. Can you find this document over there? PPT. All of you, please check. Confirm.
Yeah, we have access to those files.
I have already uploaded. Both 2 p.m. and 6 p.m. guys. Please check it now.
Yeah, it's there.
Check your drive access.
Yeah, I seen it. Thank you.
Yeah. Ivan, please check. Pepsi, please check once. In your drive access, do you have that document?
I'm checking.
Yeah, I have access.
Yep. Okay.
Yes, I've seen it.
Oh, perfect.
Thank you.
Guys, now please note down the tasks. Tasks are IKE V1, phase 1, main mode, 6 message exchange. So you have to do research on these 6 message exchanges. And while learning this 6 message exchange, you guys also have to understand what is NAT-T. Right? So these are your 2 tasks. Please check in your Zoom chat, guys. I have given these 2 tasks. Please note it down. Don't go for quick mode. Don't go for aggressive mode. Only go for main mode. Understand only main mode, nothing else. Don't run after anything else. I guess for today, this much is enough because next level of explanation, we can have after completing our main, after doing a research of main mode. Okay. So our target is to complete all these message exchanges, guys. Okay. Our target is to complete this part. Once we are done with this, after that, we'll do practicals. Okay, after that only we can move for practical. So get ready with all this stuff. I'll see you guys next week, sharp at 2 p.m. IST time. Meanwhile, please go through all the videos. I'll upload video after 1 hour, guys, and I'll update you guys in a group as well. Okay. Again, before ending the class, I want to know, is there anyone who hasn't received drive access? Once again, I'm asking because unnecessary noise is getting created in a group. Okay. I keep asking 10 times in a class, do you have drive access or not? Few students will not attend class and they will keep asking about drive access, drive access. That creates a confusion. Okay. See you guys next week. Take care. Bye.
Okay, thank you.
Bye bye.
Yeah, I said.